Hello my dear GATE aspirants, myself Madhushekar, faculty at AS Online and AS Engineering Academy. I am here going to discuss about GATE 2026 Score Booster series. So in this YouTube session, I am going to discuss numerical based questions and multiple selective questions. Okay, no? So I hope you are practicing well. So don't lose hope, especially in this period, like in December and January, most of you people lose their confidence. They'll deviate from this preparation. So don't lose. So practice daily lot of numericals. If there is any possibility, practice at least 40-50 numericals daily. Remember the formulas, practice numericals. Okay, the GATE is 90% of the numericals they'll ask you. So if you are having good command in numericals, if you remember good like formulas, then you can easily score GATE. Okay, now see here, the question here it is, a workpiece of 30 mm diameter and 40 mm height. See here, in this question, a workpiece of 30 mm diameter and 40 mm height, is compressed between two platens in an open die forging process. So this question is related to forging. Assume a perfectly plastic material with a flow stress of 300 megapascal. Perfectly plastic material with a flow stress of 300 megapascal and coefficient of friction mu is 0.23. The forcing load in kilonewton at 25% reduction. So, reduction in height. So, listen carefully. They are asking the forcing force. So, forcing force, how will you calculate? The flow stress of the material into, okay, area, final area. Okay, AF or A1 you can take. Okay, into, but in this question friction is given into 1 plus 2 mu RF by 3 HF. This is the formula. If you remember the formula, you will get the answer, otherwise you can't. Okay. Now here, in this case, they are not given the final diameter. Even final height is not given, but instead of giving that, they said 20% reduction in height. 20% reduction in height means how much left? 75% left. So, listen carefully. If H naught equal to 40, then H final or H1 is what? 0.75 into 40. This is H final. And we know D naught is equal to 30 mm. All are in mm. Okay, now first we should calculate the final diameter. Okay, so here volumetric change is 0. So because of change in volume is 0, so I can write A naught H naught is equal to AF HF, right? Otherwise we can write D naught square H naught is equal to DF square HF. So I want DF. So DF is equal to D naught into under root, okay, H naught by HF. DF is equal to under root D naught into under root H naught by HF. So D naught is how much? 30 into under root H naught is 40 by HF is 0.75 into 40. Right? What is the answer? Tell me. Take GATE calculator and solve it. Tell me what is the answer for first of all. Diameter. What is the diameter? First tell me. What is the diameter? Under root I'll directly take 1 divided by 0.75 ANS into 30, that is 34.64 mm. 34.64 mm final diameter I got. Now we'll substitute in this equation. See, the forcing force is equal to flow strength of the material into final area into 1 plus 2 mu Rf by 3hf. Suppose if mu is 0, then you can take directly flow stress into area, right? So here Yf is how much? 300 into area pi by 4 into 34.64 whole square into 1 plus 2 into mu is given 0.23, okay, into Rf. See, if this is a diameter, then radius you will get 34 means 17.32, right? 17.32 divided by 3hf, 3 into final height is how much? 0.75 into 40. Now solve this question by using gate calculator. Solve it. By using gate calculator, solve it in terms of kilonewtons. So you'll get this answer in newtons. So let us consider 2 into 0.23 into 17.32 divided by 3 into 0.75 into 40. This value is 8.85 into 10 power minus 2, ns plus 1, 1.008. So like that in gate calculator, okay, you can take 1.088 you can take. Now pi by 4 into 34.64 whole square into 300 into 1.088. So final answer you got, final answer 307.60, okay, kilo newtons, okay, 307 point. Actual answer by doing calculator 3.07 into 10 power 5 Newton, right? So 307 kilo Newton. I hope you understood this question, okay? So like that you should solve this question. So remember, calculator play a key role. Even though if you know the formula, if you do a mistake in the calculation, you'll get wrong. So be careful. There's a lot of time, sufficient time is there. Okay? Okay, na everyone? Are you following? Right. Now, next question. See, which of the following statements about a grinding wheel are correct? Now, option A, abrasive grains act as a cutting tools with a negative rake angle. Say yes. In a grinding wheel, remember, in a grinding wheel, each abrasive material act as a one tool. It is a multi-point cutting tool, grinding wheel you can say. So each abrasive particle act as a one tool and with negative rake angle. So this is correct. This is correct. First statement is correct. Then second, the bond materials determines the hardness of the grinding wheel. Yes, obviously the bond materials like silicon carbide, alumina, right, and the silicon nitride, right, sand like SiO2, these materials will decide the hardness of the material. And open wheel structure is preferred for soft and ductile materials. Yes, Open wheel structure is preferred for soft and ductile material, and closed wheel structure is for hard and brittle material. Okay, now that is also correct. This one is correct and this one is correct. Then dressing increases wheel grit size. This is absolutely wrong. The grit size of a grinding wheel is constant. That depends on during the manufacturing time they will decide this. The grit size may be a 40, maybe a 60. Okay, it is going to be decided at the manufacturing level only. So by doing dressing of a grinding wheel, the grit size will not change. Generally dressing we are doing to whatever the finishing is there, that remove that one and then increase the abrasiveness of the tool, like a sharpness of the tool, to increase that one we are doing. Okay, now so dressing increase the wheel is absolutely wrong. So that A, B, C are correct for this question. So it is a multiple selective question. In this question, A, B, C all are correct. A, B, C are correct. I hope you understood. Next question. See, a 4 mm thick aluminum sheet of width, see listen, 4 mm thick aluminum sheet of width, this is H naught I am taking, width is 100 mm. Width is 100 mm. Thick aluminum sheet of width 100 mm is rolled in a 2-roll mill with a roll diameter of 200 mm. Roll diameter of 200 mm each. The flow stress of the material in megapascal is, sigma or S or YF we can take 207 plus 414 into E, where E is the true strain, assuming rolling to be a plane strain deformation. So plane strain deformation means width is constant. The ideal roll separating force, remember they are asking ideal. Ideal means we are not considering friction. Ideal roll separation force for maximum permissible draft. Maximum permissible draft is in dash kilonewton. Now listen carefully. I'll take one new slide and then I'll explain. Okay, let us consider. Now you can take the given data here. Generally, roll separating force, okay, for ideal rolling, remember, for ideal rolling, okay, roll separating force or rolling force, or rolling force, I can write it as 2 by root 3 into y bar f into projected area. Projected area is nothing but length of the deformation zone, y bar f into length of the deformation zone into width. Okay, now, but in this question, initial thickness is given, final thickness not given. In this question, flow stress equation is given. See, remember, flow stress equation here it is given. Flow stress equation. What is flow stress equation? Remember, I am modifying the symbols. I'll take YF, but here S is given. This is true strain. E means true strain, but I'll take epsilon T. Okay, na? For easy understanding. 207 plus 414 epsilon T. This is the given flow stress. But from this, I want to calculate average flow stress. And that too, initial thickness I know, that is 4 mm. Initial thickness I know 4 mm. Initial thickness H naught equal to 4 mm. Initial thickness H naught equal to 4 mm. But final thickness is not given. So we should calculate the final thickness to calculate the strain. So we should calculate the final thickness, but in this case we should assume one assumption, but don't worry, in the exam paper definitely they will give you consider friction mu equal to 0.1. Okay, don't worry, I forgot to add this one. Now H0 is given, we don't know H1, so I am using maximum permissible draft condition. So maximum possible or permissible draft formula I am using, that is delta H max is equal to mu square R. From that I will calculate H1. See, H0 minus H1 is equal to mu square R, H0 equal to 4, H1 we don't know, mu is 0.1 whole square, radius of the roller, diameter is 200, radius is 100, right. Then from this you will get 3 mm. Now you will get 3 mm. From this calculate epsilon t, that is ln H0 by H1, that is ln 4 by 3. Now next we should calculate average flow stress also. How will you calculate average flow stress? By equating energy equilibrium, y bar f into epsilon t is equal to 0 to epsilon t into yf into d epsilon t. We should use this equation. Now see here, y bar f into epsilon t is equal to 0 to epsilon t into, what is the equation? 207 plus 414 into epsilon t. So from this I will get 207 epsilon t plus 414 epsilon t square by 2. Right. So from this y bar f is equal to 207 plus 207 into epsilon t. 207 plus 207 into epsilon t, because if I bring this side, epsilon t will cancel out. So I will get this equation. So what is epsilon t here? Tell me, what is epsilon t? What is epsilon t? ln 4 by 3. This is 0.2876. Now I will substitute y bar f is equal to 207 plus 207 into 0.2876. So how much? 207 plus 207 into 0.2876. That is 266.5 megapascal. So from this equation I got the average flow stress, and they are not asking calculate the rolling force, practical rolling force, ideal rolling force they are asking. So I am neglecting this friction, so that if I go with this, rolling force is equal to y bar f 2 by root 3 into 266.5 into L means under root R into delta H. R is 100 because diameter is 200. Delta H is 1 into width of the strip is 100. So very simple question. Now see here, this is 10, this is 100, so 1000. 1000 means kilonewton. Okay na? 1000 means kilonewton. Yes, correct. 1000 means kilonewton. Now 2 divided by root 3 into 266.5. So 307.72 kilo Newton, because this is kilo. This is kilo. Approximately we will get the answer 207.72. I hope you understood. So, for GATE exam, especially from the rolling, they will ask you lengthy questions. So, read the question carefully. Read the question carefully. Consider each and every point. In this question, ideal rolling force they are asking. H1 is not given. H1 I am calculating from the maximum permissible draft. I hope everyone is getting. Okay, na? Everyone is getting. Shall I move to the next question? Shall I move to the next question? Okay. Right. Now the question is from actually a metal cutting. Now, in an orthogonal machining operation, the cutting tool has a rake angle of 12 degrees and chip thickness before and after the cut are 0.55 mm into and 1.2 mm respectively. Calculate the shear plane angle. So, they are asking shear plane angle. Now, what is the given data here? What is the given data? Given data is given here. Rake angle alpha is 12 degrees given. Okay. Chip thickness before T0, I'll take 0.55. Chip thickness after cut 1.2 mm. Before and after 0.55 mm, 1.2 mm. This is the formula. This is the data given. So, what is shear plane angle? How will you calculate shear plane angle? See, remember, I need shear plane angle, that is pi. So, the formula is tan pi is equal to r cos alpha. Tan pi is equal to r cos alpha by 1 minus r sin alpha. Here r represent chip thickness ratio. So, chip thickness ratio r is what T naught by Tc, that is 0.55 by 1.2. So, tell me first, calculate chip thickness ratio R value. Chip thickness ratio R. So, try to calculate chip thickness ratio R and then substitute in this, you will get the answer. Okay. 0.55 divided by 1.2, that is 0.458. 0.458 chip thickness ratio. Now, from this, substitute in this equation, that is 0.458 into cos 12 degrees by 1 minus 0.458 into sin 12 degrees. Okay, cos 12 degrees and sin 12 degrees. Now, from this 0.458 into cos 12 degrees ANS divided by 1 minus 0.458 into sin 12 degrees. Sin 12 degrees. So, by solving this, you will get 0.4951. Okay, you will get 0.4951. From that, pi is equal to tan inverse 0.4951. Tan inverse 0.4951, that is 26.34 degrees. So, 26.34 degrees. So, this is the calculating the shear plane angle. So, remember, this formula is very, very important for exam. I hope everyone is getting. Have you got the same answer? Let me know if you have any doubt, please let me know. If you have any doubt, please let me know. Okay, na? Are you following or not? See here, are you following? Please, if there is any doubt, please comment me here. Okay, na? Right. Now, let us consider the next question. Next question. Here it is. Here it is. Which statements about slip gauges are correct? Which statement about slip gauges are correct? See, ringing occurs due to molecular attraction. What do you mean by this? Suppose I'll take two slip gauges. If I attach both, they will not slide. Do you know why? Because there is a molecular attractive force between two surfaces, so that they are going to be attached, they are going to stick to each other. Even if you see in metrology lab, you can see that one, they are not going to slide because of very high smooth surface finishing. Due to the molecular attraction, there is a ringing occur. Ringing means sticking the slip gauges. Sticking slip gauges. Okay, now slip gauges are made up of high carbon steels or ceramics. So generally slip gauges are made up of high carbon steels or ceramic materials. That is also correct. So first one is correct, second one is also correct. Third one, slip gauges are used for direct measurement. First of all, recall direct measurement equipments. Vernier calipers, direct measurement equipment. Directly you can measure the length, you can measure the diameter. Screw gauge, micrometer, all these are directly we can measure. But will you measure by using slip gauges directly? You can't measure. That is indirect approach. So this is not correct. Then temperature variation affects the accuracy. Yes, temperature variation affects the accuracy because of change in temperature. There is expansion and contraction of the slip gauges. Due to that, micro level errors you will get. That's why here, out of all these four statements, C statement is wrong. So answer is A, B and D. A, B and D. I hope you understood. A, B and D. Now, I hope everyone got. Next I am going to another question. Now you can see, I'll take another slide for this. I'll take another slide for this. Okay. Now you can see, in a turning test using a coated carbide tool, in a turning test using a coated carbide tool on a hardened alloy steel, the tool failure occurred after 29 minutes. Remember, tool failure occurred after 29 minutes when the cutting speed was 125 meters per minute. Okay. Now, next, in another test using the same tool and work, the tool failed after 10 minutes when the cutting speed was 165. So if I increase the cutting speed, tool life is going to decrease. Okay. At 125 speed, tool life is 21 minutes. At 165 speed, tool life is 10 minutes. Right. Calculate the value of N and C in Taylor's equation. So sometimes they'll give you four options, N value and C values. Now we will calculate. It's a very simple concept. Now listen carefully. T1 is 21 minutes and V1 is equal to how much? 125 minutes per minute. 125 meter per minute. T1 is 21 minutes and V1 is 125 meters per minute. Then T2 is 10 minutes. T2 is 10 minutes and V2 is 165 meter per minute. 165 meter per minute. Right? Now, I am using the Taylor's two-life equation. Taylor's two-life equation. Taylor's two-life equation, that is Vt power n is equal to constant. Right? Vt power n equal to constant. Now see here, V is 125 into 21 power n is equal to constant. I'll apply the log on both sides, okay, now, so that easy to, okay, log 125 plus n log 21 is equal to log C. This is first equation. Okay, now this is first equation. Now by using the second equation, remember second equation I will get 165 into 10 minutes 10 power n is equal to constant. So that from this I will get log 165 plus n log 10 is equal to log C. Log 125 plus n log 21 equal to log C. Log 165 plus n log 10 equal to log C. So, two equations. By solving these two equations, you will get the value. By solving these two equations, you will get the n value from first. Now, see here. Let us consider minus, minus, minus I will take. Now, you take log 125 minus log 165 minus 1.2, this is minus 1.2. Next, you will take log 21 1.3 and this is log 10 is 1. So, plus 0.32 n is equal to 0, right, is equal to 0. From this 0.32 n equal to 1.2, n equal to 1.2 by 0.32. So, 1.2 divided by 0.32. Sorry, there is a small correction here. This is 0.12, small error. This is 0.12, not 1.2, 0.12, okay, 0.12. So, not, sorry. Let us consider this is 0.12, 0.12. So, now you can take 0.12 by 0.32, you will get approximately get 0.375. Okay. Once again I will cross check. I have a doubt here. Listen, I will cross check this one. Log 125 minus log 165. Yes, 0.12. Next, log 21. Yes, 1.322. Okay, 0. Correct. 0.375, right? Now, n value I got from the equation. N is equal to how much? 0.375. I'll substitute this n value in any one of this equation, either first or second. Suppose I'll take first equation and substitute log 125 plus 0.375 log 21 is equal to log C. Right. Now, from this, you can take log 125 is equal to 2.096 plus log 21 into 0.375, that is 4.958 is equal to log C. Now, 4.958 plus 2.096 7.54 7.054 you will get. So, C is equal to tell me how will you get 10 power 0.54. I will check it. Power 7.054. It is not correct. There is some error here. I will just check it. There is a mistake here. I will just check it. Log 21 NS into 0.375. 0.49 instead of I took 4.958. 0.495. Okay. If 0.495, if it is that one, okay, if it is 0.495, now very simple. Now see here, 2.096 plus 0.495, right? You will get 2.591. So C equal to 10 power 2.591. So here 10 power 2.591, that is 389.9 you will get. So like that, N value and C value will get from the equation by just if you remember this equation, apply log on both sides. Two equations you will get by solving these two equations, you will get the final answer. You will get the final answer. I hope you understood. Okay, everyone. But calculation, be careful. Even I did a mistake here, calculation. So be careful regarding the calculations. If you did mistake in the calculation, you will lose marks. Okay, na? If you did calculation, you will do marks, right? So is there any comment here? Comment? Is there any comment? Right. I am going to discuss the another one. Now, let us consider this one. Okay. Here it is, a 500 mm long cylindrical workpiece having a diameter of 500 mm long cylindrical workpiece having a diameter of 130 mm, okay, is to be turned in 6 minutes. Is to be turned in 6 minutes. Time is given. If feed is 0.35 meter per revolution, if feed is 0.35 meter per revolution is used, what cutting speed must be used to perform the turning operation? So, what cutting speed must be used to for this turning operation, they are asking. So, first of all, the time equation T is equal to L by F into N. Okay, time T is equal to, for turning operation, L by length of a cylindrical workpiece by feed into, okay, revolution per minute. Now, from this, T is given 6 minutes is equal to L is given 500 by feed is given 0.35, feed is given 0.35 into N. We do not know N value we should calculate. From that we will calculate the velocity or speed, cutting speed. N equal to 500 by 6 into 0.35. N equal to 500 by 6 into 0.35. So, use calculator, 500 by, okay, 6 into 0.35. You'll get 238.09 RPM, revolution per minute. Right. Now, from this calculate cutting speed. Cutting speed is equal to okay, pi dn by 60. Remember, cutting speed in terms of meters or meters per second I will calculate, that is pi into diameter is how much? 130 mm. So, I am converting into meter, 130 into 10 power minus 3, and the speed is 238 I will take. 238 revolution per minute is there, that's why I am taking in the denominator 60. Now try to solve this question. Take the numeric calculator and solve it. Now see here, pi into 130 into 238 divided by 60. You will get 1.62 meter per second. 1.62 meter per second. I hope you understood this question. Okay, 1.62 meter per second. It's a very, very simple question. From this equation I am getting revolution per minute and from that I am calculating cutting speed. Now, let us consider this statement type question. Now see here, listen, which of the following statements are correct? First statement, continuous chips are formed while machining ductile material at high cutting speed. So, remember, continuous chip, when it is formed, for a ductile material it is going to form, and also the speed must be high, so that the first statement is correct. First statement is correct. Now, discontinuous chips are always undesirable. There is a value here. Here they use a word always, that's why I will decide later. Next, build-up edge is promoted at low cutting speeds. Remember, build-up edge promoted at low cutting speeds. Okay, yes, the build-up edge is going to be formed at low cutting speeds. And serrated chips are common in machining titanium alloys. Serrated chips is nothing but sawtooth like chips. Okay, these are mainly formed in the titanium alloy materials, like brittle type materials, titanium alloy materials. So the third statement correct, fourth statement correct, but second statement, suppose if we was not given this word always, then maybe correct this one. See, discontinuous chips may not be desirable every time. Okay, discontinuous chip is suitable for brittle material, right? For ductile material, suppose you take iron piece, if there is a discontinuous chip, tool life will decrease. Tool life will decrease, speed is not controllable, and sometimes forces are going to be induced, forces are going to be increased, so that discontinuous chips are always undesirable. That is value, always is given value. But sometimes, listen carefully, okay, like you can say, sometimes it is desirable, especially for brittle materials. For brittle material, due to the brittleness, the chip is not going to be in continuous form, so that it is desirable for brittle material. It is desirable for brittle material. Cast iron, brass, okay, not always desirable. They are not always desirable, so that it's a vague statement, so I will not accept with B statement. So A, C and D I will go. A, C and D I will go. Okay, for brittle material it is desirable. Now, next step. Listen, I will give a space, one slide space I will take here. Let us consider. Now, in an orthogonal machining operation, the cutting force and thrust force are measured as 1650 Newton. The cutting force and thrust force are measured as 1650 Newton and 1340 Newton respectively. Cutting force and thrust force both given. Find the shear strength of the work material based on the following machining data. So, rake angle is given alpha 11 degrees, shear plane angle is given pi 26 degrees, chip thickness before cut is given 0.6 mm, width of the cutting operation, width of the sheet during the cutting operation is 3.2 mm. So, what is the data given? See here, given data you can take. Now, the cutting force is given, cutting force is equal to 1650 Newton, 1650 Newton, and a thrust force is given 1340 Newton, thrust force 1340 Newton, thrust force is given 1340 Newton, and they are asking shear strength of the material, shear strength in terms of megapascal. So, how will you get shear strength actually? Shear strength is equal to shear force by sheared area, shear force by sheared area. Now, in this question, in this question, shear plane angle we should use. So, shear plane angle is given 26 degrees. Now, tell me, how will you calculate shear strength, Fs? Tell me, how will you calculate shear strength? Very simple, cutting force into cos phi minus thrust force into sin phi. Cutting force into cos phi minus thrust force into sin phi. So, cutting force is 1650 into cos 26 degrees minus thrust force is 1340 into sin 26 degrees. Okay, 1650 into cos 26 degrees minus 1340 into sin 26 degrees. Now, you can take this one, 1650 into cos 26 degrees minus 1340 into sin 26 degrees. How much? Here we got 895. Remember, 895.59 kilonewton. This is the shear force. Now, calculate sheared area. Remember, sheared area. So, sheared area AS is equal to, okay, T naught into width W by sin pi. Now, the chip thickness before cutting is 0.6, width is 3.2, 0.6 into 3.2 divided by sin 26 degrees, sin 26 degrees. Now, from this calculate sheared area, 0.6 into 3.2 divided by sin 26 degrees, that is 4.379 mm square. Now, from that, listen carefully, from that I am using shear strength is equal to shear force by sheared area, that is 895.59. I want in megapascal, that's why I am converting into Newton, 10 power 3 by mm, that is 4.379, directly I am taking, you will get Newton for mm square, that is nothing but megapascal. So, that is nothing but megapascal here you will get. Now, from this, listen, wait, I think this is in newtons, right? This is in Newton, no need to convert into, no need to use 10 power 3 because it is not kilonewton, I thought it is kilonewton, Okay, directly we will get. Now, see here, calculate this value. 895.59 divided by 4.379, that is 204.5 megapascal. 204.5 megapascal. So, in the question they gave cutting force, thrust force and shear plane angle. So, by using that we are calculating shear force, then from that we are calculating sheared area by using uncut chip thickness and then width, then we are taking the ratio of shear force by sheared area. Okay, na? This is a simple question. Now, listen carefully. Here, a 100 mm long cylindrical workpiece of diameter 50 mm. Okay, length of the cylindrical workpiece is 100 mm. I am taking the given data, and diameter 50 mm. Diameter 50 mm is reduced to diameter 25 mm. So, D1 is equal to 25 mm, D0 equal to 50 mm, D1 equal to 25 mm. The flow curve for the metal has a strength coefficient K is equal to 750 megapascal and strain hardening coefficient is 0.15, right? Assuming no friction, but 50% redundant work is given. 50% redundant work, they are asking, okay, required extrusion force. Okay, redundant work is given, be careful. Redundant work is given, that is 15%. Now listen, extrusion force formula is what you know, okay, Y bar F, okay, into, okay, A naught initial area ln A naught by A1. This is okay, and in the question 15% redundant work is given. So, ideal, this is ideal formula, ideal plus 15% if I take, I am going to multiply 1.15. Okay. Now, calculate Y bar F. Y bar F is equal to, first calculate epsilon T, that is ln 2 ln D naught by D1 or ln A naught by A1. So, that 2 ln 50 by 25. Okay. So, epsilon T is equal to 2 ln 2. I already said to you even in the classes also, for competitive exams you should remember ln 2 value. ln 2 is 0.68 or 69. Then into 2 if I take 1.38 you will get. Now from this Y bar F is equal to K epsilon T power n by n plus 1. So K is 750 into 1.38 by 0.15 by 1.15. So what is Y bar F? Try to calculate what is Y bar F. 750 into 1.38 power 0.15 divided by, what happened? Wait, 150 into 1.38 power 0.15 divided by 1.15. You'll get 684.45 megapascal. This is Y bar F. Now, from this, listen, 684.45 into pi by 4 into, okay, D naught is 50 square into 2 ln 2 into 1.15. So solve it. Now solve it from this equation, complete equation, solve it. Now first I will take pi by 4. Pi by 4 into 50 square into epsilon t is 1.38 I will take, that is 2 ln 2 into 1.15 into 684.45. So what is the answer? Approximately 2132.79 kilo Newton. You will get it, right? So this is the answer. So like that, you should calculate the numericals mostly from the production. For gate exam point of view, they will ask you the numericals only. So be careful, remember the formulas, daily practice 30-40 questions, definitely will get a good gate rank. All the best for you.